the urinary system. This is the last recorded lecture of the material for your third exam. As we discussed at the very beginning, we are going through two processes. One is excretion and the other is elimination. And excretion occurs at the level of the kidney, and elimination is going to occur through the urinary tract. So how do we get this urine that was made due to the process of excretion and get it through the urinary tract and remove it from the body? So the urinary tract is composed of your ureters, your urinary bladder, and the single urethra. Remember, there are two ureters. You can say ureters, but the more common pronunciation is. All right, so let's do an anatomical overview of the organs that are necessary for removal of urine and storage of urine. So this is your urinary bladder. In a male, this is the ureter. And you can then see that this is called the external urethral sphincter. So this is the urethra, right? And we'll talk a little bit more about that in a minute. But because this is a male, let me point out to you this structure, which is the prostate gland. So things are a bit different in a male. Also note that your bladder is between the pubic symphysis and the rectum. For the female, the bladder is a bit higher. So this is a section of the bladder. It's been transected. So this is the urinary bladder. This is the urethra right here. But notice what is above, and this is the uterus. I think the human body is an amazing, absolutely amazing design, with this one flaw. Look at the uterus and then place a 10-pound bag of potatoes in there and think about what happens to the urinary bladder. You can understand why one of the reasons why a woman has to urinate more when she's pregnant is because of the pressure on her bladder, number one, and number two, she's urinating for two individuals. All right, so let's look at the bladder a little more closely. This is the bladder of a male because we have the prostate gland encircling a structure called the prostatic urethra, right? So for the male, there are three different areas of the urethra, right? But this is the urinary bladder, and let's pay attention to the openings here and here for the ureters, right? So the ureters, muscular tubes, they go from the kidneys to the urinary bladder. They begin at a place called the renal pelvis of the kidney. They are actually attached to your abdominal wall. They penetrate the posterior wall of the urinary bladder. They do pass through the urinary bladder at what is called an oblique angle. And the openings in the urinary bladder are slit-like. They're not rounded. And that shape and the position of them helps to prevent a backflow of urine, because your urinary bladder is much like a balloon, and when it fills with water, imagine your hand squeezing a water-filled balloon. So you could see how urine could easily go back up the ureters, but because they have the shape and position that they have, it makes it much more difficult. There's three layers of your ureter walls. There's the inner mucosa, and then there's the middle muscular layer. It has longitudinal and circular bands of smooth muscle. So you know that whenever you see longitudinal and circular bands of smooth muscle together, that you can just about guarantee that peristalsis is going to occur in that organ. And then there is this outer connective tissue that's fibrous, it's very tough, and it is continuous with the renal capsule, so the capsule that goes around the kidney. Those peristaltic contractions begin at the kidney, at the renal pelvis, and they have a sweeping motion all the way down the ureter. Every 30 seconds, they force urine toward the urinary bladder. So when you're asleep and you wake up in the morning and you stand up and the first thing you feel is that need to urinate. Well, urine has been making its way to your urinary bladder the entire time you were sleeping. So when you stand up, you're putting additional pressure on some sphincters that we'll talk about a little bit later. The urinary bladder, again, is much like a balloon. It's a hollow muscular organ. This is a temporary reservoir for the storage of urine. You can have up to 1 liter of urine in the urinary bladder, but it does vary from person to person. You saw in the images of both the male and the female anatomy that they're in essentially the same place, but the female's is just a little bit higher. There are peritoneal folds that hold the bladder in place, and there are bands that anchor the bladder to the pelvic bones and to the pubic bones. Coming off of the urinary bladder, you can see that there are umbilical ligaments. There's one here and one here. This used to be umbilical arteries, and as you develop, they change into these ligaments. So there's also the middle umbilical ligament right here, and that middle umbilical ligament goes toward and attaches close to your belly button, where your umbilicus was. And then these lateral pass along the sides of the bladder toward the umbilicus. So inside the bladder, you have folds, and those are called rugae, and they're not permanent. They do disappear as the bladder fills. There is an area of the bladder that's called the trigone. It is bounded by the openings of the ureter and the entrance of the urethra, right? So it is a triangle. This area acts as a funnel so that urine can flow from the bladder into the urethra. All right, so in this image, I'm going to indicate to you the trigone right here. These were the urinal openings, and this is the opening to the urethra, right? So the urethral entrance, it lies at the apex, and it's the most inferior point, this point right here. So the neck of the urinary bladder has a muscular internal sphincter, right? So this is the internal urethral sphincter right here. It is smooth muscle, and it is under involuntary control, right? Involuntary control. The walls of the urinary bladder have mucosa, submucosa, muscularis layers. It forms the detrusor muscle of the urinary bladder, and that allows for contraction to occur and for the expulsion of urine. The urethra goes from the neck of the urinary bladder to the exterior of the body. For males, it's 18 to 20 centimeters in the. If you look at the male urethra, like I said earlier, it has 3 parts. The prostatic urethra passes through the center of the prostate gland. So you can understand why, if a male has an enlarged prostate, they may have difficulties with urination. The next part of it is called the membranous urethra. That's the part that it's short and it penetrates the urogenital diaphragm. And then the spongy urethra, or sometimes it's called the penile urethra, is the part that is found in the penis, and it goes from the urogenital diaphragm to the external urethral orifice. All right, to show this again, here is the prostate gland. This is the prostatic urethra, and this is the internal sphincter right here. The external sphincter, which is in the urogenital diaphragm, is found right here. This external sphincter is made up of skeletal muscle, and it is in your control. So the internal urethral sphincter will release, and you voluntarily control the removal of urine from your body at the external urethral sphincter. The female urethra is much different. It is only 3 to 5 centimeters in length. It goes from the bladder to the vestibule, and the orifice is near the anterior wall of the vagina. So in both sexes, it has that band of skeletal muscle, the external urethral sphincter, and this is where the urethra passes through the urogenital diaphragm. This is about voluntary control. It's controlled by the pudendal nerve. It has muscle tone, and so a person has to keep the muscle in tone in order for it to work effectively. So think about this in an infant and think about this in an older adult, right? What type of control do these individuals have that are different than a healthy adult that is in homeostasis? So as I stated at the very beginning, urination, the word can be interchanged with the word micturition. So the reflex is actually called the micturition reflex, and this is a reflex that coordinates the process of urine removal from your body. So when you get to about 500 milliliters or more of urine in your urinary bladder, you have stretch receptors that will be stimulated, and those receptors will then stimulate the pelvic nerve. That stimulus goes from the pelvic nerve and stimulates ganglionic neurons in your bladder. A postganglionic neuron in those ganglion is going to stimulate the detrusor muscle, so that allows for the detrusor muscle contraction so that the bladder will squeeze. While this is going on, you have interneurons. Remember, those are the traffic cops of your nervous system that relay that sensation to the thalamus in your brain, delivers the sensation to your cerebral cortex, and that tells you then to voluntarily relax your external sphincter, and your internal sphincter will then release. That's a lot of nervous system involvement, so you can understand that there is control that one must expend when they are trying to not urinate. But remember, the ability to urinate means that you must relax in order to be able to do so. So if you think about a toddler who is trying to be potty trained, and you want to go shopping, so you set them on the toilet and you tell them they need to pee. Well, it's kind of difficult for them because maybe they don't have all of those neural pathways established. Or maybe it's an adult that has what's called bashful kidneys or bashful bladder. Bashful kidneys really doesn't make any sense, but that's what it's called sometimes. And then they have difficulty urinating in public. So think about the toddler again. What happens? You have to be able to make that toddler relax. So you have them sing or read a book, say their ABCs, and they finally relax so that they can urinate. So they lack voluntary control over urination. Young infants and some toddlers, they just don't have the connections. But as you get older, the changes are a little different. Incontinence may be an issue, and that's the inability to control urination voluntarily. You just don't have the same number of functional nephrons. They have a reduced sensitivity to antidiuretic hormone, and a person will have difficulties, may have difficulties with the micturition reflex. Problems that can happen as age-related problems that can happen include the sphincters losing muscle tone. If a person has some type of central nervous system issue such as a stroke or Alzheimer's disease, that can cause problems with micturition. And as we talked about earlier, in males, urinary retention can develop due to an enlarged prostate gland.